Right, so we are going to just make some notes based on what we were talking about last lesson, and then you're going to do the exercise in the textbook, which is this one here, practice 3. So you're going to use the skills. So we just want to make sure we've got some stuff down there. Even if you fully understand, that's great. But let's talk about, just in case we've missed some vocabulary, terminating decimals. How do we write it as a fraction? Right, you all understand what a terminating decimal is?
Yes.
Yeah? What's a terminating decimal?
Non-repeating.
Nope.
A decimal, like, with a finite amount of numbers?
Yeah, okay, so for instance, 0.3 is a terminating decimal. Now the reason why I said it's not about non-repeating, because for instance, 0.212121 is a repeating decimal, but it terminates. Yeah?
It dies after a period. It terminates.
Yeah, it terminates, it stops. It doesn't go any further.
It has
Micah, Dash, you ready? I've given you a pencil, can you use it please? I'm really not impressed, and now I'm on video saying I'm not impressed with you. Alright, so who can tell, what do I mean? So I'm just going to write a figure 0.3. What do I mean by use place value to turn this into a fraction? Got it?
Because if you put them into columns,
Yeah. So I'm just going to put a line down through the decimal points. And I'm going to draw my columns in. This is the units column, or the ones. The next column after the decimal point is the tenths column, and if I went to the next one, it would be hundredths. So that means because I've got a 3 in the tenths column, the fraction is 3/10. Yeah. I mean, we could also, like for instance, if I put a 0 there, which is not a problem, I could do that. I could also write 30 over 100, yeah. 30 in the hundredths column. But we know that the 3/10 is the equivalent and simplified one. But those two are the same, but we would divide by 10 and to keep that. So what about this one then? I mean, I wrote this, I tell you what, I'm going to get rid of those two. So we've still got a repeating but terminating decimal. What would that be? Someone different? You're not different. You're the same person. I don't want you to. I get you understand it. Aaron? Okay, so we take the numbers like we were doing in that criterion B. So the 3 goes over 2,121. Then we need to figure out which column it is. So this is the tenths, hundredths, thousandths, and then it's a bit of space, 10,000. So that's the column. So we know it's the 2,121 over 10,000. Okay? If we have 0.0402, Michael, what do you think? $402, yeah. Same value here, isn't it? We have to go. So this is the tenths. This is the hundredths. Sorry, this is the thousandths, and the 2 is the 10,000. So it's again the 10. The reason why I gave you that one is hopefully don't get confused by extra zeros and things. You just look at the place value there. And one final one before we move on, unless anyone's got any problems they would like to discuss. What if we did 3.01? Okay, what do you think about this one? can't just ignore the 0. Like this one, look. We've got a 0 between. We didn't write 42.
So that was 301.
301
It's top heavy.
over
Over 100.
over 100. I'm happy with that. It is top heavy, someone said that, it's an improper fraction. But that's not a problem. But there is another way of writing it, which some people would like to give you. 3 and 100. Yeah, that's another way. Okay? Those two are the same thing. So I'm happy with either way. Unless, so this would be called improper fraction.
The other one would be proper.
This one's called a mixed number because it's got a whole bit and a fraction bit. Yeah? Okay, so we've kind of dealt with terminating decimals. They're quite easy, right? Just using the place value. So, what was the next thing we looked at last lesson? Recurring. Okay. Is there anyone still writing notes there? Question there? Okay, well, I'll talk about that right at the end because we're not quite at that stage yet. Those are not recurring. Oh, sorry, these ones are not recurring, these are terminating. Alright, is everyone finished writing their notes? Next year with me, you finished writing your notes? Yeah, try it, just done? Cool, right, I can move on, yeah? The next thing then that we're adding to our notes to make sure we've got is we're going to talk about recurring decimals. And an example of a recurring decimal would be, say, 0.4. Do you like the dots or do you like the line? Line. It's supposed to be straight. But, well, I prefer the dot because you put a dot at the beginning and a dot at the end, whereas a line has to go along everything. So if you've got a long recurring number, you have a long line, which can get messy. But up to you, if you want to use it. I'll stick to what you are happy with. So if you're happy with the line. What does that mean, by the way, the line? Alyssa, what does that mean? What does the line here, what does it mean of how? What's a recurring decimal? Recurring does mean repeating, actually, exactly that. What can I write? What does it, how would I represent that? Not as a fraction, just as a decimal still, but what would I be looking at if it was recurring? If I didn't put the line, what would I see? Alright?
If we didn't put the line, you would just see 0.4.
Just that? Yeah. Nothing else? Not quite, no? Because
You would have a lot of 4s.
we have a lot of 4s, wouldn't we? How many 4s? An infinite number of 4s, yeah? Keeping on going on all the way to infinity, which doesn't actually happen, it's just an idea, it's a concept. So we put a line to represent the number that repeats, because we can't write an infinite number of 4s. Alright, so if I were to write a 0.06 with a line across the 0 and the 6, okay?
Yeah, it would just be 0, 6, 0, 6.
No, 0, 6, 0, 6, 0, 6, 0, 6. Just to say, guys, if I were to put this into my calculator, did a calculation that ended up with this number, why would I see this on my calculator? So, on my calc, I would actually see 0.0606061. Does that mean it's not a recurring one anymore? Cora, what do you think?
It just means it's not going to go any further. It's not.
Yeah, what do you think, Shia? It's rounding, actually. The calculator can only give you a certain number of numbers, right? It gets to a certain point, and it wants to write a 0 to end with, but it's not allowed because it rounds. So the 6, the next 6 rounds the 0 up to a 1. So don't get confused that that is not a recurring number. You have to. This is where you have to be smarter than the calculator and interpret what it says. Just because it's quite a simple piece of equipment, really. It's not as complicated as like one of your computers or something. So, yeah, it gets programmed around it. That's why you have to be smarter than it, you know. Charlie? Pardon? Yeah? I imagine that you can code them to sort it out. All right, now, here's the thing. We kept it simple last week. Who can remember what 0.4 recurring as a fraction is? Ash? 4 over 9. Do you remember what the way to decide that is? No? Dexter? Do you have to explain it to someone?
Like the place value, you know how it would actually be 10 because it's like the two numbers, but since it's a recurring number, you always go 1 down. So if it's like 4 place values, and it's like that, you go 1 down to 99.
Okay. Yeah, that's one way to think of it. So this is in the tenths column, so we take what is only a 9. There is another way to think of it, which might be slightly easier for some people to think. Charlie, what do you think?
4 divided by 9 equals.
Well, how do I know it's a 9? Why did Dash know it was 4 over 9? I mean, I can show it, but if I have no idea, I wouldn't even get to the 4.
4 divided by 9.
But how would I know? So, for instance, the next question is 0.06 recurring is what? As a fraction. And I can't say, well, because, oh no, I don't know what it is, so how can I say because that is that? Seb?
It would be 6 over 100. 99.
6 over 99. Okay. Alright. Now, I think one way that people were saying was if you look at your recurring decimal, you take the number of digits that are recurring and you have that many 9s underneath. So 2 digits recurring, that many 9s. Why didn't I put 0.6 over 99? Okay.
Because it doesn't matter. If you put a 0 or a 6, it doesn't matter. Because that's not going to the right. It's not affecting the place value.
Yes, this 0 doesn't affect the place value. It's got a place value of 0, so we don't put the 0.6, we just put the 6 over 99. But it does matter for the 9s, doesn't it? Alright, one more. Imai, come and sit down quickly. Come on. Do your sharpening when I've finished. Just one quick one before I let everyone get going. So 0.413. If I did give you a question where the dots were above the 4 and the 3, what would that one be, Imai? So it's like the line going across everything, but I put a dot at either end. What's that as a fraction, remember? So remember the rules. It's how many digits are repeating? 3. So how many 9s go underneath? 3. So we have 9, 9, 9, because there's 3. What goes on the top? Just those numbers. 4, 1, 3, right? What have I not tried to do with any of those at the moment? What have I not tried to do? Charlie?
You haven't made only some numbers repeated, like 4.
Okay, no, so that's different. What have I not tried to do with these specific ones? Is that a school jumper there, Alyssa? School uniform? No?
Simplify.
Aaron, what have I not done?
Well,
He's just told you the answer. So. Keep it simple, give me his answer again. It's not simplified. I've not simplified any of these. So I could potentially try and simplify. Okay? So make sure you've got your notes sorted. Alright? And then this page in the textbook, starting at page 64. Now, however confident you feel, you can go towards the end ones if you like. but you've got a mix here of all of the types of questions, fractions and percentages.